So let us now continue focusing some additional areas where you can utilize multi-bodies. Okay. So when we use multi-bodies in conjunction with some of the existing technologies in Creo, like flexible modeling, it becomes a super powerful feature. Using flexible modeling, it's really powerful, as you know, and we can utilize to move or single or multiple bodies, and we can make fast direct edit to the modeling body geometry. You can offset geometry from single or multiple bodies if you like. I'm sorry about that. Okay, use feature recognition tools within flexible modeling to edit rounds and patterns and things like that. Okay, so in this example, I started with the one side of the model, and then I basically move it, I rotated it with the flexible modeling. I can actually do the merge in between different bodies. I can create additional features in between, and finally I can merge all of them together to create a complex shape. Okay, making use of flexible modeling to easily create that design in few seconds or minutes if you like. Okay. Additive manufacturing, another area that hugely benefit from multi-body. These days additive manufacturing become more complex. We can simplify that process with the body-based control and definition of build process. You can create and manage and visualize different lattices structures to different bodies, and when you print them, you can treat them as separate parts. Assign colors per body to improve the visualization. You can validate the clearance and interference between the bodies. You can define printing strategies by assigning different printing and building profiles to individual bodies. Also, the body colors are supported through 3MF export. In summary, we can analyze and measure the bodies as independent models and more granular control of the additive manufacturing. Another important area is again simulation. Multi-body design will simplifies the analysis and setup for FE and CFD simulations. Now bodies can be defined in different design process. Like an example here, like a valve or a plunger, and the fluid geometry can be different bodies. Bodies can be assigned different materials as required for analysis. Bodies can be used as a construction geometry to define the analysis setup and also to reflect the accurate mass properties, because construction bodies have no mass. Bodies can define cavity bodies for CFD simulation domain selections. And also now bodies can be moved to define different states, or like I said, we can apply the simplifier representations to create different configurations. That is the out-of-box functionality again inside a Creo, but when we actually combine these two together, it become again very powerful. Another area will be generative design. Generative design is very breakthrough technology inside Creo to autonomously generate the 3D model for you. Based on the starting geometry and preserved geometry and the excluded geometries we designate, and all these geometries can be selected as a body. We can create different bodies for starting geometry and preserved geometry and so on, and we can easily select, and we can designate those bodies, and those autonomously generated the result we can be also treated as a body. And also when you recreate the model as a B-rep geometry, that also can be managed as a body and merge the preserved body with the generative designs and so on. And again, you can use the construction body to concept to reflect some of the correct masses if you really like to. Some of those bodies can be considered as construction bodies, and they won't be considered for mass properties. All right, so let us have a quick look again inside Creo. Let's just close a couple of those models which I showed you before, and let us start with let me just start with the lattices. So here in this example, I got two different bodies. Okay, so that's outside is the main body, is the outside geometry, and I got a separate body for that creating the lattices. Now, when I actually create the lattices, I can actually go and say, select that bodies. If you have multiple bodies, you can easily select that lattices and assign different lattices into different bodies in one single part. Okay, we got different lattices inside Creo, like a beam and 2.5D and formula-driven stochastic lattices and so on. You can easily select a body, and you can have different lattices for each individual bodies. And of course, as I said before, each lattices or bodies can have different materials. So I can easily assign material properties for each individual lattice bodies here. And also I can assign colors. When you actually take this one to a tray, and when you export this one into a 3MF format, system will take that whole properties you assign inside a Creo into your 3D printers. As we know, 3D printers these days are equipped with printing multiple materials, multiple colors, and so on. And with the multi-body concept, we can simultaneously print multiple bodies within same part, but of course in reality they are individual parts. Okay. Another area I would like to show you here is the CFD analysis. So what I got here is 3 different bodies. Okay. So I got a cylinder body. If I just show you, isolate that body. So this is the cylinder body is outside, and then I got a fluid body, which is the inside fluid body here. Okay, and also I got a control valve here. So at the moment, they all are designed as individual bodies, so easy for me to design things. I can simply isolate my body here for the fluid. I can actually optimize this fluid body. And now, again, before I doing any analysis here, I can actually assign material, maybe a water, maybe a oil, or some sort of a fluid I can easily assign individually. You can see that flexibility of creating things as multiple bodies here or by simulations. Now, what I can do here is now I would like to do some Boolean operations. For example, I would like to create a body subtract between that plunger, and then if I just isolate that body, I create a cutout using the plunger here, okay, or the valve here. And if I just go and create a cross-section analysis to show you here, okay, so here I got a that cutout is being created using the position of the plunger here, the valve here. Okay, so now what I'm going to do here is I already have predefined some of the simulation here. I'm using the live simulation on all the fluid domains and the boundary condition. Everything is being set up in the already. So now I can actually go and run the analysis to on the spot instantly to check the result. That is the beauty of live simulation. I know this is not a live simulation webinar, but just to show you that combining all these different technologies within Creo, we can actually benefit that. And now if I just go and maybe I got a flexible modeling tool here. If I now flexible feature here, which originally I move that surface a little bit up, maybe I just change it the position again and regenerate that. You can see the analysis now update. You can actually capture this position as a closed or an open contact if you like. You can actually create a family table to define that configuration of open and design. You can create a simplified representation if you like to capture that different position and rerun the analysis based on the value position. Okay. So using that core concept of the body, I can easily define this, analysis and define, adding all these functionalities together, make it a super perfect features and a very powerful system as Creo. Now, last but least, maybe I would like to also show on the generative design. Okay. So in this example, so what I got here is a generative design setup, which is already pretty much done. We can see the loads, the constraints, everything is being done. For the generative design, what I'm trying to do here is, again, I got few bodies here set up, okay? And what I'm really like to do is design a new geometry here as a connecting body between these inside this bracket here. the existing my model shape for the existing model shape is that's that start geometry which I'm highlighting at the moment. But this is very bulky, and I would like to create something special, which is maybe a lightweight solution. Okay, I'm just hiding that for the time being. So what I can now do here is I can actually go and use the starting geometry as that model. Okay, so I created that as a starting geometry. Now I can actually select that as my preserved geometry. And also I can actually go and use some of that screws for extruding. Maybe I'll just pick that screw, maybe that 2 other screws to extrude some geometries here. Okay, and of course I can add the loads and the constraints and also the manufacturing constraints, and then system will go ahead and create an autonomous geometry for me. Okay, that is the generative design. Now what we can actually do here is, because I can easily select and control that starting geometry and preserved geometry and extruded geometry, I'm just making use of the body concept to simply to designate that geometries easily here, rather than selecting some surfaces or some solids, so hard for me to do the selection. I got a video created up front so that we can easily, it will take some time to create that design. So, once we designate those geometries here, now I can actually go and create I can also apply the manufacturing constraints, how you like to do the actual manufacturing of the new model. You can also assign the physical properties of the material, and system will go ahead and create the geometries. Okay, it's going to be an accelerated video just to show you the concept, but here in context of the multi-body, once you created this new design, I can treat this new design as a separate body. I got the option to merge with the existing body, and also I will get the option to create a new body. Okay, so once I have done that, and maybe I created a new body, again I can actually easily manage that inside my model tree. I can rename it as I go, and easily I can rename it, and you can maybe make it as a construction geometry, for example. Maybe you would like to stop the generative design at this stage, because maybe all you need is a concept rather than using this using this geometry. Maybe if you like to continue and create a B-spline representation of converting that into surfaces, you can go ahead and do that. Again, at that point also, you can have the option to make it as a separate body and merge bodies, and using the Boolean operation to merge with your existing shape and so on. Okay, again applying that whole concept of multi-body in different applications of Creo.